put in like one of the kids, like you need to put in a bus.
Okay, I hate to interrupt all this great stuff. And I have some more great stuff. But as they say in the internet, your mileage may vary. Last time we introduced, kind of just a little bit on the slide, something that I was using to process some strings that were coming from a movie database. And in the process, I was using a very powerful thing called regular expressions. And so today we're going to basically dip our toes into it. I mean, it's a very complicated, in a way, it's a language all of its own. Nevertheless, if you're writing programs and doing any text processing, it is very important to have this in your toolkit. And so after today, you will. There's a handout on the, I think it's in the download section of the resources on Sakai. Basically, it's just a one sheet that summarizes all the basic things with regards to regular expressions. Today, I'm just going to kind of expand a little bit on some of them. The ones that I have found in my work to be particularly important. So a regular expression, you'll see it as regex, because why? Because people like to kind of use fewer syllables. And all it is, it's a sequence of characters that match text programs, text patterns. In a way, it's like you've no doubt used the star as kind of a wild card, like when you're searching for something. And that in the star or asterisk, depending on how you look at it, actually has a specific, slightly different meaning in regular expressions that we'll talk about. But in Java programming, at least, there are three main use cases for this. The first is to match text patterns to identify certain portions of text. So, for example, if you have a blob of text and you say, I want to find all of the words, you know, what a word is something which is a little bit up in the air, but I want to find all the character strings, at least, that match this particular pattern. That's one. Another significant use case is, okay, I want to find all of the text that matches this pattern and replace it with something else. You know, you've all used the basic replace facility, like in a Word document, for example. There, you don't have, as far as I know, I don't think the Word supports regular expressions. So if I want to find all instances of a particular word and replace it with another word, then you can do that, but you have to know exactly what the word is. With regular expressions, again, since, as we'll see, it's a little language for identifying much more general sets of patterns in the strings. And so in Java, there's a command that you can do which replaces all text that matches a particular regular expression pattern with another specific string. And then the final use case in Java is what we saw last time, which is splitting the text into different elements. In the last class, we did two splits. The first split was we were reading a line that was tab separated. And so for the first split, we split it into elements separated by the exact tab. And it was the tab and nothing more. And that's something that I'm asking you to do with the next assignment. And then within that, the issue was that there was one of the columns, as it were, had a comma-separated list of possible genres. So you had something that could be both a a comedy and a horror, or a sci-fi and a romance, or just a dessert topping and a floor wax, whatever those are. And so, not knowing what a particular one was, that one was sort of split a little bit more. Now, it turns out that in that particular set of text, there weren't any, say, spaces in the commas, between the commas. But if you are doing something like processing a comma-separated file, which is actually a more common thing than the tab-separated, as the movie said. But we talked about why it was tab-separated, not comma-separated. But comma-separated is a more typical one. So in a comma-separated situation like that, you would typically split it with commas. But in many comma-separated files, because they're plain text, a lot of times you'll have like commas and spaces and other types of things. So, and you typically, if you only split it on commas, then those spaces are going to be in your data, and that can kind of mess things up sometimes. And that's why in the regular expression that I used, I was splitting it on one or more spaces and commas. We'll see about that. But splitting text into elements is the third use case. And Java has methods that support that. Okay, so delving into what this regular expression language is. The first is just matching text. Okay, so the basic wildcard in regular expressions is the dot. And a dot matches any single character of any kind. Now, if I type in a letter or a number, for example, then that will match the exact character. And if I have a string of these, then it matches it exactly. So, where did my mouse go? Come on. Okay, it's doing something, but it's not showing me where the heck it is. Nah. Okay, so the string hi mom with the space in it, it matches hi mom and nothing else. In other words, if I just give it a string of specific characters, then it'll match that specific string of characters and nothing else. And that's what we're mostly used to if you've done any searching or replacing in Word documents, say. Okay, but hi dot mom, okay, since the dot matches a single character of any kind, that will match. Why are you not? There we go. Okay, so, oops. All right, so if you say hi dot mom, the dot is going to match anything in there. So that'll match the original hi mom, but it'll match hi x mom and hi $ mom or hi 9 mom, because it'll match any character in that middle space. But it only matches one. So hi XX mom, it will not match because there are two characters there. Or hi mom with nothing in between, it won't match because there's nothing there. Or like with two at characters, whatever. Okay, so that's really the first one. So letters or numbers will match that exactly. The dot will match any specific single character. Say, well, that seems kind of restrictive. Well, then they introduced this idea of having character ranges. And the square brackets that you saw in the thing that I used to split says, pick any one of these. So, for example, the regular expression ABC in brackets like this, it will match A or B or C, but not any two-character combination or any letter that is not that. So it will not match capital A, for example. Now, one thing to remember is that these are all case sensitive, so it will not match A, capital A, because that doesn't match one of these three. Now they have some shorthands for things, so what if I want to match any lowercase letter? Well, if I say A hyphen Z, that means A through Z, and so that matches any letter of either case. Any lowercase letter, sorry. Reading. Now, what if I want to match any letter of either case? Well, I can have lower A to Z, capital A to Z, and that will match one letter of either case. And I can string these together. So if I have hi in brackets and mom in brackets, that will match any two letters, any specific two letters, with the first one being either H or I, and the second one being either M or O. So it'll match hi M, or I-O, or I-M, but nothing else. So it'll match exactly 4 combinations of these. And we can string these together. Similarly, we can match, a single number. I didn't list this, but if I have a single number, say 3, that will match the number 3. But if I want to match any particular digit, I can say 0 through 9. And so what that should tell you is within the bracket, the hyphen means a range. So 0 through 9. If I only want to do, say, 1 through 3, I could do 1 hyphen 3. Or if I wanted to do only, say, A through B, A through C, I could say A hyphen C. Now within and this is a little confusing because the up arrow character has 2 different meanings depending on where you put it. The first one is if we put it inside the bracket as the first element, then that will negate everything that follows. So up arrow ABC within the bracket will match any letter except A, B, or C. And that works with ranges as well. So up arrow A through Z, capital A through Z, matches any character except a letter. So you should now start to, even with what has been done so far, at least when it comes to matching a single letter, that there's a very rich set of possibilities that go significantly beyond just matching the exact text that you're typing in. But wait, there's more. Okay, there are 3 basic actually dot is technically a wild card, but and I think this has a slightly different technical name, but I like to think of, well, wild card may not be the best descriptor of this. But anyway, the 3 are question mark, plus, and star. So first, question mark. So question mark says what happened, what came immediately before it is either there or not there. So so hi mom with the question mark, it matches hi mom, because that's one, but it also matches hi mo, because the last M is not there. And I said, and the expression said that because it put the question mark after the M. And again, with all of these, it matches, they refer to the one thing that immediately came before it, the one thing. The plus so that matches 0 or 1. It could be there or not. But a plus now, it matches 1 or more. Okay, so hi mom plus, okay, it'll match hi mom, and hi mom, because the plus said there could be 1 or more M's at the end, but it will not match hi mo because the M is missing. So the plus says there has to be at least one of them there. And finally, star matches 0 or more. So hi mom star, that will match hi mom because it'll also match high-mo because the star modifies the M and says that can either be there or not, and there can be as many of these as I want. Okay, so this will match all of that. Okay, so that's a way that we can now. I mean, up to now, everything has been like kind of one thing, but these can be used to have more than one thing, especially the plus and the star. Okay, so we can put them together with the character range. So, for example, A through Z plus says one or more letter, lowercase. So that will match hi mom with no space. It won't match a space, I'm sorry, it won't match an empty string because there needs to be at least one thing there. It won't match hi mom with a capital H because the capital H is not a lowercase one, and it certainly won't match anything with a space in it because that's not a letter. This will not match this final hi mom because it requires all the letters to be lowercase and no spaces, or nothing that's not a letter. Okay, remember the question mark is either there or not. So question mark A through Z. Now that'll match the empty string because that says if it's not there, it's not there. And it'll match, say, H, but it won't match high because there are two of them. It says 0 or 1. Whereas A through Z star, it matches the empty one because nothing can be there. It'll match hi mom and any sequence of nothing but lowercase letters, but it won't match this because the uppercase, and it won't match this one because of the space. And there's even more, and this is where it gets to be very, very interesting. And those are meta. I know meta is the big word now, especially in, but the meta character. I mean, they've been calling these meta characters for decades. So anyway, so a backslash is used to escape certain letters that have specific meanings. So this 0 through 9 was such a common one that they came up with the \D, and that will match any single digit, lowercase d for digit. Okay, it'll match, and again, the orientation, as I hope you're starting to get, is that the basic, the basic character pieces match like 1, and then you use the wildcard things to expand on it, and the brackets to give a choice. So \D will match 1, but it won't match 1, 1, or A1, and it won't match a letter either, because it says match exactly one digit. The opposite of that is you'll see the pattern here, is that if we take the meta character and you make it uppercase, then that negates it. So \D will match any single non-digit. So it'll match capital H. It won't match high because it only matches 1, but it won't match 8 because it says match anything that's not a number, not a single digit. Now they do have the other special one is \W for word. They probably should have made it L, but the problem with that is that a lowercase l on the computer looks an awful lot like 1. So the W is for word, except it doesn't match a word, it matches only a letter. But it matches letters, numbers, or underscores. So \W is basically equivalent to, so A through Z lowercase, A through Z uppercase, 0 through 9 digit, and underscore, all within a bracket. You know, so instead of writing all this thing out, you have \W. So that'll match H, it'll match underscore, it'll match for, but it won't match at because there are any special symbol. And to negate that, you make it capital. So \W, that will match any single character that's not a letter, a number, or an underscore. So \W, it will match at, it'll match a $, but it won't match H, underscore, or 5 because it says do not match something that's a letter, a number, or an underscore. Okay, the last two important meta characters are \S, which matches any single white space. Okay, what is white space? It's spaces, tabs, new lines, carriage returns. There's kind of due to, back when dinosaurs ruled the world and there was still some question about what particular computing platforms would dominate, there were different meta characters that told the console or the printer what to do. And some of the things like that were, well, a tab, which would tell you to tab over. That was based on, all this kind of goes back to typewriters, basically. If you can ask your grandparents about what typewriters are, but there would be a tab, and you know, that would move it would actually move the carriage over like that. And so the carriage was a thing on the typewriter that moved back and forth. And so when you reach the end of the line, you kind of basically, usually, if it was a manual one, you'd have to kind of hit a little lever and it would kind of go back to that and then move to the next line. But moving back to the start of the line and moving to the next line were two different operations. And so there's one meta character, \R, that returns you to the beginning of the line but doesn't advance the line, and another one that advances the line, whereas \N advances the line. So, and so the carriage return refers to that carriage on the typewriter. In case you know. I mean, these days, you know, when finish a phone call, you hang up. Well, what the hell? Where does that come from? Back in the day, you had to actually literally hang the thing up. Anyway, just all these newfangled things, which are these young kids, just anyway. Okay, so \S, that'll match a space, a tab, or a new line, and then there's a \R, other sorts of things. Now, and this is where it can come in handy. A lot of times there's, in fact, I've encountered this in some of the databases that I've been working with the Navy, is that they'll have these databases and the entries will have a bunch of spaces in them. Why? Well, my hypothesis is that they've been converted from earlier formats that had fixed widths, and so they'd pad them out with spaces. But that can that actually kind of was creating problems initially until I realized what was going on. So I mean, I'd be reading these things and I'd read stuff and I'd go to read something and it would come in all weird, and then I realized it was coming in with all these spaces and stuff. So the thing is that you don't know how many of these are. So if I put a plus on my \S, then that'll match a single space, but it'll match a whole bunch of spaces, and it'll match any sequence of non-printing characters. Like here, I have a tab, a new line, and another tab. This will match that. Now again, by making it a capital, that matches any non-white space character. So \S, it'll match H or $, and just about anything that's not a space. And then if I put a plus on it, it'll match, you know, I'm sorry. oops, this is incorrect. It will not match that, but it'll match this because this has no spaces in it. It won't match that because it has a space in it. Now, the thing about these meta characters is because you indicate them with a backslash, then we have a little problem when we're trying to use them in Java, and actually in any programming language, because in all programming languages these days, the backslash is the escape character. That goes back to the C language, which is the granddaddy of all modern languages. And so, just like if you've been working with full path names on Windows in strings, you notice that the path separator, the backslash, you got to do it twice. Okay, why is that? Because in the string, the backslash is the escape character, and so if you encounter, if I say no, I don't want to have an escape character, I actually want the backslash. You have to escape the backslash. So the first backslash escapes the next character. And if the next character is an escape character, like a backslash, then it escapes the escape, if that makes sense. So inside the string, we will always have to use double backslashes to specify that. And hopefully when I get through this, I'll show you some examples. Now, we can also, remember I said that the caret, or the up arrow, has two different meanings. We saw one where it negated something inside of a bracket, but we can also use it outside of the expression as the first element. And what that says is only match something at the start of the expression. So if I have an up arrow caret high and then a space and then one or more letters, that will match hi mom, but it won't match oh hi mom because it said only match the thing if it starts with this. At the other end, the $sign specifies the end of a string. So if I said hi, a space, one or more characters, and then ending with an M, $sign, that will match hi mom with one, hi mom with lots, but not, well, in this case, not hi mom, because it didn't end with a small m. And then this isn't really a boundary, but kind of an either or. But if I put a pipe, or if I put whatever this thing is called, between them, then this says match either this or that. This is a and so this will match either hi or mom, but not the full thing, because it'll only match one or the other. Okay, so here's some more examples. So here this says start the match with bat, and then have one or more. Actually, sorry, this should have been a star. That was my mistake. So that'll match bat and Batman, but not wombat. And if I have one or more words before bat, that will match bat, and it'll match wombat, but it won't match Batman because it didn't end with bat. Okay, now with respect to numbers, they say, well, so far we can make digits, but a lot of times we have floating point numbers. So how do we deal with that? Well, first of all, remember, because the dot has a special meaning, if I want to say I really mean a dot and not a wildcard character, I have to escape that. And I escape it by giving it a backslash. And because within the string, I need to say I really need a backslash and not an escape indicator, I need to escape the backslash. So in order to escape the dot, and again, that's the general principle. If if I say I want to match the literal star and not use star as a wild card, then I have to escape it. So anything that's used as kind of as one of these meta characters or wild cards, if I say I really mean the thing, then you escape it. So \d plus, it'll match any integer as long as there's at least one number, but it will not match a floating point number. Why? Because there's a dot in there. It fails. The dot is not a number. Okay, well, what if I wanted to match a decimal number? Well, here's one thing that will match at least some, not necessarily all. This will match. Okay, so what is this? Again, we can decipher this. I have a \d star that says 0 or more digits, followed by a dot, and I mean a dot because I've escaped it, followed by 1 or more digits. So that will match, 3.141. Why? Because it has 0 or more digits, followed by a dot, followed by 1 or more numbers. It'll match 0.25. Why? Because I say 0 or more digits beforehand, it's got 0. That matches. And then a dot. There's the dot. And then 1 or more digits there. But it will not match this. Why? Because it doesn't have a dot. You say, well, what if I wanted one that will match floating point numbers or integers? Well, one way would be to kind of expand on this a little bit and say, now the dot is optional. So now I'm saying I want a dot there, but the question mark says, maybe not. Okay, so 0 or 1 dots, preceded by 0 or more numbers, followed by 1 or more digits. So that will match all 3 of those. But it won't match, like if I have 2 dots. It will not match that. You know why? Because it says only 1. And that's fine because this isn't a number. Okay, likewise, and this is something that I was using for the splitting last time, and you should now hopefully be able to see a little bit. Okay, \s, that's any space. And the comma, now a comma, because a comma isn't a special character, a comma is just a comma. So those are in brackets. So plus says match any combination of commas and spaces. Now this actually has a little bit of an issue because it'll also glom multiple commas. So this isn't perfect by any means. I mean, it worked for that particular input that I was using, but it was not sufficiently general. But it got the job done. So it'll match a single comma. It'll match a comma surrounded by spaces. It'll match a tab. It'll match a tab followed by, that should be a comma, etc. Any combination of white space and commas on either side will match. Okay, so it's use in Java. So first, string, and these are strings. Like here, all my S's are strings. The string class supports a number of different operations with regular expressions. So one is, if I have a string, can I tell whether or not it matches? And this, I think, is a well-named method. Again, you should always name your methods in a way that describes what they do. So S matches a regular expression. That's going to be true if it matches and false otherwise. Again, so it's like you don't you don't really need to even read the documentation if you name your methods well enough. Okay, so now replacing, there are 2. First is replace first, and I need to give it 2 arguments. So Again, this is an instance method on strings. If I say replace first, I give it a regular expression followed by just a plain string that's the replacement. So the replacement is always just a plain string, not because remember, for a regular expression, that just matches things. And here I'm saying I want to take everything that matches this regular expression and I want to replace it with this specific string. And so replace first, guess what that does? It finds the first match and it replaces it with the replacement. So if my string is hi to mom, and I want to replace the first digit with a space, then that will replace the 2 with a space, producing this. But if I have hi to mom 2, replace first digit, space, then that'll give me the first space, but not it won't replace the second one. And actually this is a little, oops, there would be an extra space here, by the way. Okay, so replace all, guess what that does? It replaces all of them. So hi mom 2, if I replace all with all the digits it finds with a space, it will, and again, I'll have to fix the slides a little bit. There would be a space here and a space here. Okay, and the final use is something that we've seen already, which is split. And so that's a little, once you start using it, it's kind of evident, but it's well named, but it just, split is not as descriptive as matches or replace. Okay, so if I have hi comma mom split comma, what it does, as we've seen, it will take a string and it will turn it into an array, and based on the delimiter specified by the regular expression. So if I have hi comma mom and I split it on comma, that will produce the array hi in the 0th index and mom in the 1st index. And if I have here, it's hi tab space mom and new line dad, and I split it on one or more spaces, one or more white space, that will produce the array. Okay, here I have a tab and a space, but it'll just sort of swallow all that. I'll have hi and then mom, and this new line is a white space, and so I'll have the and dad. Okay, so I think I have time to do some examples here.